Hello students, welcome to your channel Parivartan Physics. See, we are in the series of videos where we are going through rapid revision course for KCET 2025, in which we are revising one chapter in one video rapidly. All the concepts, shortcuts and formulas of each chapter we are revising in this quickly, right? So we have completed up till electromagnetic induction, and in this video we are going to see about alternating current. Dear students, I have also solved KCET PYQs of each chapter from second PUC physics of 7 years, 8 years, 10 years, 5 years, like this I have solved. And the link for that playlist is given in the description box. Please go through that and you will find the KCET PYQs on each chapter of second PUC. Right? Okay, let us begin the video without making any delay. Okay, let us start. Alternating current. See, we know very well the instantaneous voltage and instantaneous current, right, is given by V is equal to V naught sine omega t and I is equal to I naught sine omega t. These both are instantaneous values, where V naught and I naught are peak values, right? Peak value antandre maximum value of voltage and maximum value of current, right? Omega means it will be equal to 2 pi f. Okay. See, these both the current as well as voltage, alternating current as well as alternating voltage will be varying like this. So, to reach the maximum value, this is the peak value, positive peak value, and this is negative peak value. So, to reach the maximum value from 0, it will take t by 4 time, right? So, this is one complete cycle of AC. So, to complete one cycle of AC, how much time it will take? It will take time period, capital T. Right? So to reach from 0 to peak value, it will take this much time. From here to here, to reach this much, it will take t by 4. 1/4 of the time period it will take to reach the maximum value. Okay, well, after that, average voltage is given by 2 V naught by pi, 2 V naught by pi, and average current is given by 2 I naught by pi, right? These are the average values. So this is average current. See, average values are 63.7% of the peak value. Peak value is 63.7, somewhere here it will be. It is less than peak value, right? 63.7% of peak value is average value. After that, RMS value. RMS value is equal to peak value divided by root 2. Peak value divided by root 2, which is 70.7% of V naught, right? And RMS value of current is peak value of current upon root 2, which is also 70.7% of I naught, which is greater than I naught is greater. See, I naught is greater than I naught, peak value is greater than IRMS, and IRMS is greater than average value, right? So peak value is greater than RMS value is greater than average value, right? So remember these things. We'll go for the next concept now. Okay, next is a pure resistor circuit. Now we'll see AC circuits. In that, first one is very simple, pure resistor circuit. Only resistor we have connected in this circuit now. See, when only resistor is connected across an AC source, voltage will be V is equal to V naught sin omega t. This is the voltage which we apply. V is equal to V naught sin omega t. And the current in the circuit will be I is equal to I naught sin omega t. So if we see both the equations, we'll get to know the phase difference between voltage and current is 0. Right? In pure resistor circuit, current and voltage both will be in phase, so the phase difference will be 0. So here we have shown it graphically. This is voltage and this is current. Both are attaining their peak values at the same time and negative peak value at the same time, and they are becoming minimum at the same instant. That's why we are saying that both are in phase. So phasor diagram is here. Both the vectors should be shown along the same straight line so that the phase difference between them will be 0. Next, R is independent of the frequency of AC. Whatever variations you do in the frequency of the AC, it will not affect the resistance, right? So frequency, new AC frequency increase madri or decrease madri, it will not affect the resistor. It will make the difference in case of inductor circuit as well as capacitor circuit, because those inductive reactance XL and capacitive reactance XC will be dependent on frequency. So by varying frequency, XL and XC will vary, but by varying frequency, R will not vary, right? That we'll see how it happens in inductor as well as capacitor circuits. Okay, we'll go for the next circuit now, pure inductor circuit. Whenever a pure inductor is connected to the AC, at that time, the voltage applied is V is equal to V naught sin omega t, and current in this circuit will be I naught sin omega t minus pi by 2. So how much is the phase difference here? Here phase difference is pi by 2. In pure inductor circuit, phase difference is pi by 2. In pure resistor circuit, phase difference is 0. Right? So here what happens, as we can see here, it is minus pi by 2. It indicates that current is lagging behind the voltage by 90 degree. Current lags behind the voltage by 90 degree, or you can say voltage leads current by 90 degree, pi by 2, right? So here I have written I lags behind V, or V leads I by pi by 2, right? And see, inductor is such an element which opposes the change in current. It will not oppose the current. Inductor will not oppose the current, it will oppose the change in current. So here we are passing AC through that inductor. AC means it is the current which always changes its magnitude and which changes its direction periodically. Magnitude continuously change ಮಾಡ್ತದ್ರೆ, direction periodically change ಮಾಡ್ತದ್ರೆ. So it is a changing current. So when you pass such AC, changing current in the inductor, that inductor will start opposing that AC. So that opposition offered by the inductor is called inductive reactance, and it is given by XL is equal to 2 pi FL or omega into L. So here it is clear that XL is directly proportional to frequency. As you go on increasing the frequency of AC, it starts opposing more. It ಜಾಸ್ತಿ ನಮಗೆ ಅಪೋಸ್ ಮಾಡ್ಲಿಕ್ಕೆ ಶುರು ಮಾಡ್ತದೆ. Its opposition will be more, right? See, for DC frequency is equal to 0. Therefore, the inductor will not oppose that DC. Inductor will not oppose DC. It will oppose AC only, because AC has high frequency, DC has low frequency. So inductor will not oppose DC, it will oppose only AC. For DC, inductor will behave like a common conductor, on common wire tara behave ಮಾಡ್ತದೆ. So the phasor diagram as well as graphical representation is here. Here we have taken voltage and here we have taken current. You can see voltage is starting from origin, current is starting from negative y-axis, so current is lagging behind the voltage, right? Okay, phasor diagram ನೀವು ನೋಡ್ರಿ, in two ways you can show it, both are correct. Voltage if you have taken here, current should be here. See, you have to always observe these vectors in anti-clockwise direction. Anti-clockwise direction ನೋಡ್ಕೋಬೇಕು. So current is lagging behind the voltage. ಈ direction ದಾಗ ನೀವು ನೋಡಿದ್ರೆ voltage ನಮ್ಮ current ಗಿಂತನೂ ಮುಂದದ್ರೆ, how much angle it is forward? 90 degree it is forward. Here also if you see in the anti-clockwise direction, voltage is forward than current by pi by 2, right? That's why we say the phase difference is pi by 2 and voltage is leading current, right? That's all about the pure inductor circuit. Next we'll go for a pure capacitor circuit. Here a capacitor is connected to the AC source and the voltage applied is, ನೋಡ್ರಿ ಎಲ್ಲಾ ಸರ್ಕ್ಯೂಟ್ಸ್ ಗೆ ನಾವು ಇದೇ voltage, same voltage apply ಮಾಡ್ತೀವಿ. Resistor circuit, inductor circuit, capacitor, LCR circuit, LC circuit, LR circuit, CR circuit. For all circuits, we are going to apply the same voltage. V is equal to V naught sin omega t. AC we are applying. So in this case, how much will be the current? Current will be I is equal to I naught sin omega t plus pi by 2. There it was minus pi by 2, here it is plus pi by 2. So it clearly indicates I leads V by pi by 2. So how much is the phase difference in this case? In this case also the phase difference is pi by 2. Right? So phase difference in pure resistor circuit is 0, phase difference in pure inductor circuit is pi by 2, phase difference in pure capacitor circuit is pi by 2. Correct? Okay. So here I leads voltage by pi by 2 or V lags behind current by pi by 2 ಅಂತ ಹೇಳ್ಬೋದು. See, remember inductor ಇತ್ತಂತಂದ್ರೆ it supports voltage. So voltage will lead current by pi by 2. Capacitor ಇತ್ತಪ್ಪ ಅಂದ್ರೆ C for capacitor, C for current. Capacitor ಇತ್ತಪ್ಪ ಅಂತಂದ್ರೆ capacitor will support current, it will not support voltage. So current will lead voltage by pi by 2. Right? Okay, that's all about the phase difference as well as current leading the voltage. Next, this capacitor will be opposing AC. Capacitor AC na oppose ಮಾಡ್ತದ್ರಿ, right? Resistor will oppose, inductor will oppose, capacitor will oppose, all they will oppose. It depends upon the frequency, right? So opposition offered for AC by the capacitor is given by capacitive reactance, right? Capacitive reactance, it is not reaction, capacitive reactance, right? So capacitive reactance, it is opposition offered by capacitor to the flow of AC. Capacitive reactance XC is given by 1 by 2 pi FC or 1 by omega C. So it is clear that XC is inversely proportional to frequency. XC is inversely proportional to frequency. If frequency increases, XC decreases. So frequency decrease ಆಯ್ತಪ್ಪ ಅಂತಂದ್ರೆ XC increase ಆಗ್ತದೆ. Frequency decrease ಆದರೆ XC increase ಆಗ್ತದೆ. Frequency of DC is 0, so XC has to be infinite. Frequency of DC is 0, XC has to be infinite. That's why we say capacitor will not allow DC. Right? Capacitor will not allow DC. Yes. So here we have written for DC F equal to 0, so XL is equal to infinity. So this blocks DC. Inductor opposes high frequency AC. Capacitor opposes DC. Right? This you have to remember. So here also you can observe the waveforms are given like this. This is voltage. For all waveforms I have taken voltage from origin only. Only current I have changed. So here current leads voltage, that's why I am starting current from positive y-axis. In the previous case, current was lagging behind the voltage, that's why we started current from negative y-axis. Right? Okay, here you can observe in the anti-clockwise direction, current is forward than voltage by how much angle? By pi by 2. Here in anti-clockwise direction, you can observe current is leading voltage by pi by 2, right? Both are correct. This is how we have to show it graphically as well as in a phasor diagram. Okay, next we'll go for combination of two elements, LR circuit, CR circuit, LC circuit. See, LR circuit. You remember one thing, in pure resistor circuit, phase difference was 0. It means current and voltage both were in same direction. In pure inductor circuit, what happened? Voltage lead current by pi by 2. Andre voltage ಮುಂದೆ ಹೋಗ್ತದ್ರೆ current ಹಿಂದೆ ಉಳಿತದೆ 90 degree. So phase difference in resistor circuit is 0. Phase difference in inductor circuit is pi by 2. Andre 90 degree. So here what happens? There is an element which tries to make the phase difference in between current and voltage by pi by 2. And there is an element which tries to make the phase difference 0. So in the fight of creating the phase difference of 90 degree and creating the phase difference of 0, in this case, the phase difference will be greater than 0 degree and less than 90 degree. So in between phase difference will be there. Where? In LR circuit. But still, since there is inductor which supports the voltage, here voltage leads the current because of inductor. Voltage leads the current. You can observe here, V is equal to V naught sin omega t, I is equal to I naught sin omega t minus pi. So pi is greater than 0, less than 90 degree, but still you can see it is minus pi. Minus pi antandre current is lagging behind the voltage. By how much angle? By pi angle it is lagging behind. Right? Okay, next. Here we have written clearly V leads I by pi. In this case, the opposition offered by inductor and resistor together is called impedance. Notary. Opposition offered by resistor is called resistance. Opposition offered by inductor is called inductive reactance, XL equal to 2 pi FL. Opposition offered by capacitor is called capacitive reactance, XC is equal to 1 by 2 pi FC. Opposition offered by any of the two or all three together is called impedance. LR, CR, LC, LCR, ಇವೆಲ್ಲ together combination ಬಂತಪ್ಪ ಅಂತಂದ್ರೆ ಅದರದ opposition ನಾವು impedance ಅಂತ ಕರಿಬೇಕು. So here in LR circuit, impedance is given by ZLR is equal to root of R square plus XL square. ZLR is equal to root of R square plus XL square. And here, see, this is current. Ille voltage across resistor is VR, voltage across inductor is VL. We know very well in resistor, voltage and current will be in phase. That's why we show voltage across the resistor and current in same direction. ಇವೆರಡು ಇನ್ ಫೇಸ್ ಇರಬೇಕು ನಮಗೆ ಫೇಸ್ ಡಿಫರೆನ್ಸ್ 0 ಇರ್ತದಿಲ್ಲ ಸೊ ವೋಲ್ಟೇಜ್ ಅಕ್ರಾಸ್ ರೆಸಿಸ್ಟರ್ ಅಂಡ್ ಕರೆಂಟ್ ವಿ ಶೋ ಇನ್ ದ ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಬಿಕಾಸ್ ಫೇಸ್ ಡಿಫರೆನ್ಸ್ ಇನ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ವಿಲ್ ಬಿ 0. What about phase difference in inductor? Phase difference in inductor will be 90 degree and voltage has to be front compared to current. Current ginta munde irbeku. So voltage across inductor we have shown along positive y direction. So that in anti-clockwise direction if you observe current gintanu inductor the voltage namagu 90 degree munde. Right? See, ille I have shown the resultant voltage. Resultant voltage. This is the resultant voltage. Antandre nodri voltage across inductor is VL, voltage across resistor is VR, and voltage across this whole series combination is V. Whole series combination is V. That is what we have shown here, and that will be equal to root of VR square plus VL square. Is namage irtadri. Why? Because VR and VL are perpendicular. We know very well voltage is directly proportional to the opposition, and the resistance is directly proportional to the voltage. That's why where you take VR on the same axis, you can take R also. Where you take VL on the same axis, you can take XL also. ಅಂದ್ರೆ ವೋಲ್ಟೇಜ್ ಜಾಗದಾಗ ನೀವು ಅಪೋಸಿಷನ್ಸ್ ತಗೋಬಹುದು, ಅದರ ರೆಸ್ಪೆಕ್ಟಿವ್ ಅಪೋಸಿಷನ್ಸ್ ಗಳನ್ನು ತಗೋಬಹುದು. ಅವಾಗ ಇದನ್ನ V ಅಂತ ಬರೆಯೋ ಬದಲು ನೀವು ಅಪೋಸಿಷನ್ ಆದ್ರೆ Z ಅಂತ ಬರೀಬೇಕಾಗ್ತದೆ. So we have two phasor diagrams here. One phasor diagram is in terms of voltage VR, V, VL. Another phasor diagram is in terms of oppositions R, XL, Z. Right? So both things we can show. So impedance in this circuit is ZLR is equal to root of R square plus XL square. Phase difference nodri. Phase difference bekadre ನೀವು ಇಲ್ಲಿ ಯಾವ ಬೇಕಾ ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಕ್ ಫಂಕ್ಷನ್ ಇದಕ್ಕೆ ಅಪ್ಲೈ ಮಾಡಬಹುದು ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ವಾಟ್ ಯು ನೋ. ರೈಟ್? ಇದಕ್ಕೆ tan ಅಪ್ಲೈ ಮಾಡಬಹುದು, cos ಅಪ್ಲೈ ಮಾಡಬಹುದು, sin ಅಪ್ಲೈ ಮಾಡಬಹುದು, ವಾಟ್ ಎವರ್ ಯು ನೋ. So here tan pi is equal to XL by R ಅಥವಾ VL by R. So here in this circuit also impedance will be directly proportional to frequency. Since XL is directly proportional to frequency, here ZLR will be directly proportional to frequency because inductor is there. Okay, next we'll go for CR circuit. CR circuit means capacitor and resistor circuit. So we know very well capacitor tries to make a phase difference of pi by 2 in between current and voltage. Resistor tries to make the phase difference 0 in between current and resistor. So again there is a fight between capacitor and resistor, which leads for the phase difference to become greater than 0 degree and less than 90 degree. Right? Yakandre capacitor 90 phase difference and maintain madlik try ಮಾಡ್ತಿರ್ತದೆ, resistor will be trying to maintain 0 phase difference. Hence phase angle lies between 0 and pi by 2. Okay, since there is capacitor which supports current always, hence current has to lead here. ಹಿಂದಿನ ಸರ್ಕ್ಯೂಟ್ ಒಳಗೆ ಇಂಡಕ್ಟರ್ ಇತ್ತು ವಿಚ್ ಸಪೋರ್ಟ್ಸ್ ವೋಲ್ಟೇಜ್, ಸೊ ವೋಲ್ಟೇಜ್ ಲೀಡ್ ಆಗ್ತಿತ್ತು, ಕರೆಂಟ್ ಲ್ಯಾಗ್ ಆಗ್ತಿತ್ತು. ಇಲ್ಲೇ ನಮಗೆ ಕರೆಂಟ್ ಲೀಡ್ ಆಗಬೇಕು. ದಟ್ಸ್ ವೈ ವೋಲ್ಟೇಜ್ ಅಪ್ಲೈಡ್ ಇಸ್ V is equal to V0 sin omega t, current I is equal to I0 sin omega t plus pi. Right? It means current is leading voltage by pi angle. Right? So I leads voltage by pi. In this case, impedance is equal to root of R square plus XC square. Right? R square plus XC square. Since XC is inversely proportional to frequency, ZCR will also be inversely proportional to frequency. Next, phase difference. ಈಗ ನೋಡ್ರಿ phasor diagram first ನೋಡ್ಕೊಡ್ರಿ. We know always current and voltage across resistor is VR, voltage across capacitor is VC, or resultant voltage across the series combination is V. Correct? Okay, so nodri, current in the resistor and voltage of the resistor must be in phase. That's why we are showing voltage across resistor and current in the same direction. VR matai same direction. Correct? But voltage in this circuit has to lag behind the voltage of the capacitor. It has to be lag behind the current by 90 degree. So current illada andmele voltage across capacitor namaga illi irbeku. It has to be behind the current by 90 degree. Correct? Okay, if this is VR, this is VC, then the resultant voltage will be here. Resultant voltage namage ಎಷ್ಟು ಆಗ್ತದೆ? Resultant voltage will be equal to root of VR square plus VC square, because VR and VC are perpendicular to each other. Right? So voltage across resistor, voltage across capacitor, and this is resultant voltage. The same phasor diagram we can take in terms of opposition. Where there is voltage of resistance, there you can take resistance. Where there is voltage of capacitor, there you can take inductive capacitance. Right? And here you can take the total opposition, that is Z. Impedance. Impedance is ZCR is equal to root of R square plus XC square. Here phase difference, to find phase difference you can apply tan, it will be XC by R or VC by R. Tan ಅಷ್ಟಲ್ಲ, ನಿಮಗೆ ಏನು ಗೊತ್ತಿರ್ತಾವೆ, ಯಾವ ಸೈಡ್ಸ್ ಗೊತ್ತಿರ್ತಾವೆ, ಅದರ ಬೇಸಿಸ್ ಮೇಲೆ ಟ್ರಿಗೊನೋಮೆಟ್ರಿಕ್ ಫಂಕ್ಷನ್ ನೀವು ಯಾವುದೋ ಅಪ್ಲೈ ಮಾಡಬಹುದು. Right? So that's all about CR circuit. So in LR circuit and CR circuit, phase difference is greater than 0 and less than 90 degree. In pure L circuit and pure C circuit, phase difference was 90 degree. Correct? Okay, let us go for the next circuit now. That is LC circuit. Inductor is there, capacitor is there. Here what happens? Inductor tries to take voltage forward. Inductor supports voltage. Capacitor supports current, so it tries to make current leading. This one tries to make voltage leading. Capacitor tries to make capacitor leading. Since we know very well voltage across inductor will be here, voltage across capacitor will be here. They will be opposite in direction. And voltage across resistor will be here. Voltage across resistor. Athwa ನೀವು ಇದನ್ನ direction of current ಅಂತ ತಗೋಬಹುದು. So current ಕಿಂತ voltage across inductor 90 degree ಮುಂದಿರಬೇಕು. Right? Voltage across capacitor should be behind the current by 90 degree. Right? We know very well in inductor voltage leads current by pi by 2. That's why current kintano voltage across inductor mundirabeka. In capacitor current leads voltage by pi by 2. So voltage across capacitor kintano current namak mundgade irabeka by pi by 2. Correct? So VL and VC will always be opposite in direction. VL and VC. That's why resultant voltage will be equal to VL minus VC or VC minus VL, whichever is greater minus smaller. So V is equal to difference between VL and VC. If XL is greater than XC, then VL will be greater than VC. At that time we have to say V leads I by pi by 2. Correct? So aವಾಗ ಏನಾಗ್ತದ್ರಿ, ನಿಮಗೆ phase difference phasor diagram ನಿಮಗೆ ಈ ತರ ಬರ್ತದ್ರಿ. You will get VL minus VC here on y axis and VR you will get here. Current ಮತ್ತು resistance ಇಲ್ಲಿ ಬರ್ತದೆ. So resultant will be here. Resultant voltage ಅಥವಾ resultant impedance ನಮಗೆ ಇಲ್ಲಿ ಬರ್ತದೆ. Right? V leads I by pi by 2. In this case, if XC is greater than XL, VC will be greater than VL. VC will be greater than VL. At that time, resultant you will get here. ಇಲ್ಲಿ ನಿಮಗೆ VC minus VL ಬರ್ತದ್ರಿ. VC minus VL, and here you will get resistance. ಇಲ್ಲಿ voltage resistance ಇರಂಗಿಲ್ಲ. Right? You will not be having this here. You will not be having this. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನಮಗೆ resistor ಇಲ್ಲ. That's why we don't have VR. In that place, we have to take directly current. ಅಲ್ಲಿ ನಾವು directly current ಅಂತ ಹೇಳಿ ತಗೋಬೇಕು. right? We have to take current. So this is current and this is resultant voltage VC minus VL. How much is the phase difference? 90 degree. So here you will not get resultant here. Illi namaga resultant barudilla. Will not get resultant here because resultant of voltages here VL minus VC. ಇರೋ ಎರಡು ವೋಲ್ಟೇಜ್ ಅದಾವ್ರಿ, VL ಮತ್ತು VC ಎರಡು ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ದಾಗ ಅದಾವ. ಸೊ ಇಫ್ VL is greater, resultant will be in the direction of VL minus VC, right? And if VC is greater, resultant will be in the direction of VC minus VL. Current will always be in X direction. So the phase difference is 90 degree here also, and the phase difference is 90 degree here also, correct? And if XL and XC both are equal, this is called resonance of LC circuit. Resonance of LC circuit, and in this case Z will be 0, impedance will be 0, right? And resultant voltage will also be 0 in this case. In case resultant voltage is 0. That's all about LC circuit. Next we'll go for very important circuit, that is series LCR circuit. See, we have connected a resistor, capacitor and inductor in series here. So the applied voltage will get divided in 3 parts: voltage across resistance, voltage across capacitance, voltage across inductance. And the total voltage of the series combination is taken as V. Total voltage of the series combination. See, voltage across inductor is taken along positive y direction because, see, first new current direction fix ಮಾಡ್ಕೋಬೇಕು. Current now fix positive x direction ದಾಗ ಇಟ್ಕೊಂಡಿದ್ವಿ. Current is always fixed, positive x direction. Voltage across resistor will be in phase with current. Pure resistor circuit ಒಳಗೆ ಏನಾಗಿರ್ತೈತ್ರಿ, voltage and current are in phase. That's why voltage across resistor should be shown along the current itself. Inductor ಒಳಗೆ ಏನಾಗ್ತದ್ರಿ, ಇಂಡಕ್ಟರ್ ಒಳಗೆ voltage leads current by pi by 2. That's why current ಗಿಂತನೂ voltage across inductor ನಮಗೆ 90 degree ಮುಂದ್ಗಡೆ ಇರಬೇಕು. It should be forward than current by 90 degree. What about capacitor? Voltage across capacitor, ಇಲ್ಲಿ current leading ಇರಬೇಕು voltage ಗಿಂತನೂ 90 degree. So here is voltage across capacitor and here is current. So current is leading voltage across capacitor by pi by 2. Clear? Next note. Voltage across resistor is I into R. Voltage across capacitor is I into XC. Voltage across inductor is I into XL. But voltage ಅಂತಂದ್ರೆ ಏನ, current into opposition offered by the element. All three will be opposing here. ಮೂರು oppose ಮಾಡ್ತಿರ್ತಾರೆ. Correct? Okay. ಇನ್ನ ನಮಗೆ ಕೇಸಸ್ ಬರ್ತಾವೆ ಇಲ್ಲಿ. If XL is greater than XC, then voltage across inductor will be greater than VC. ಆಮೇಲೆ ಇಲ್ಲಿ ನೋಡ್ರಿ, ಈ ಫೇಸರ್ ಡಯಾಗ್ರಾಮ್ ಒಳಗೆ ನಾವು ಇಲ್ಲಿ ವೋಲ್ಟೇಜ್ ಮಾರ್ಕ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ. ವೋಲ್ಟೇಜ್ ಜಾಗ ಒಳಗೆ ನೀವು ಅಪೋಸಿಷನ್ ತಗೋಬಹುದು. In place of VL you can take XL, in place of VC you can take XC, in place of VR you can take R. Resultant voltage, ನೀವು resultant voltage ಜಾಗದ resultant opposition ಅಂದ್ರೆ impedance ಅಂತಾನೆ ತಗೋಬಹುದು. If XL is greater than XC, VL will be greater than VC. Current in this case, ಇದು ಇಂಡಕ್ಟರ್ ಡಾಮಿನೆಂಟ್ ಸರ್ಕ್ಯೂಟ್ರಿ. ಇಂಡಕ್ಟನ್ಸ್ ನಮಗೆ ಇಂಡಕ್ಟಿವ್ ರಿಯಾಕ್ಟನ್ಸ್ ಜಾಸ್ತಿ ಅದ ಅಂದ್ರೆ ಇದರ ಅರ್ಥ this is inductor dominant circuit. So if it is inductor dominant circuit, voltage should lead, current should lag, right? That's why we write I is equal to I naught sin omega t minus pi by minus pi. Minus pi means current is lagging behind the voltage by pi angle. Okay, here what happens? See, resultant VL ನಮಗೆ VC ಕಿಂತ ಜಾಸ್ತಿ ಅದ. So VL, if VL is greater than VC, since VL and VC both are opposite in direction, resultant will be VL minus VC. And in which direction it will be? It will be along VL. Since XL is greater than XC, resultant will be XL minus XC, and which is greater? XL is greater. That's why the resultant will be in positive y direction. That's what we have shown here. VL minus VC or XL minus XC along a positive y direction. VR and I both are in positive x direction. Correct? So resultant voltage VL minus VC or resultant reactance XL minus XC is here. Current is here. Right? So the resultant voltage or resultant impedance will be here. ಇಲ್ಲಿ ನಮಗೆ resultant impedance ಬರ್ತದೆ. Hence here phase angle will be in between 0 and 90 degree. But still you can observe in anti-clockwise direction voltage is leading current because it is the inductor dominant circuit. In this case, impedance will be root of R square plus XL minus XC whole square. Impedance will be root of R square plus XL minus XC whole square. Okay, now if XC is greater than XL, ಇದು ನಮಗೆ ಜಾಸ್ತಿ ಇತ್ತು, ಇದು ನಮಗೆ ಕಮ್ಮಿ ಇತ್ತಪ್ಪ ಅಂತಂದ್ರೆ VC will be greater than VL. VC will be greater than VL. And now it can be called as capacitor dominant circuit. ಈಗ ನೀವು ಅದನ್ನ capacitor dominant circuit ಅಂತ ಅನ್ಬೋದು. Capacitor dominant circuit ಇತ್ತಪ್ಪ ಅಂತಂದ್ರೆ here current leads voltage. Current leads voltage, right? So the resultant will be VC minus VL or XC minus XL. And the resultant will be in this direction. VC ಮತ್ತು XC ಯಾವ ಡೈರೆಕ್ಷನ್ ತಗದವ ಆ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ನಮಗೆ ರಿಸಲ್ಟೆಂಟ್ ಇರ್ತದ್ರಿ. VC minus VL or XC minus XL. correct. Positive direction ಒಳಗೆ ನಮಗೆ current ಅದು, positive x direction ಒಳಗೆ. Negative y direction ಒಳಗೆ ನಮಗೆ VC minus VL, XC minus XL ಅಂತ ಹೇಳೋದು, correct. So the resultant voltage or resultant impedance will be in this direction. Resultant voltage or resultant impedance will be in this direction, correct. So you can observe still voltage is here, current is here. It means current is leading voltage by angle greater than 0 and less than 90 degree, correct. So this is capacitive dominant circuit. Here impedance Z will be equal to root of R square plus XC minus XL square. This is XL minus XC square. This is XC minus XL square because XC is greater. And lastly comes one more unique case, that is if XL and XC both are equal. If XL and XC both are equal, then VL and VC both will be equal. These both will be equal. Ivu eradu equal irta. Avaga namaga idu ಮತ್ತು idu cancel out ಆಗ್ತವೆ. These both will get cancelled, right? If these both gets cancelled, then it will act like a pure resistor circuit. See, if XL and XC are equal, VL and VC are equal, then Z will be equal to R. Z will be equal to R. Z ನಮಗೆ root of R square plus 0 ಆಗ್ತದ್ರಿ. So it will be R. This is called as resonance. ಈ condition ಕ್ಕೆ resonance ಅಂತ ಕರೀತಾರೆ, right? So for resonance, conditions for resonance are XL must be equal to XC and Z must be equal to R. Phase difference here will be 0 because it acts like pure resistor circuit. Phase difference 0 ಆಗ್ತದೆ. ಆಮೇಲೆ ಇದು ಪ್ಯೂರ್ ರೆಸಿಸ್ಟರ್ ಸರ್ಕ್ಯೂಟ್ ತರ ಬಿಹೇವ್ ಮಾಡ್ತದೆ. ಯಾಕಂದ್ರೆ ಇದ್ರದ್ದು ಎಫೆಕ್ಟ್ ಹೋಯ್ತೆ, ಇದ್ರದ್ದು ವೋಲ್ಟೇಜ್ ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತಾ, ಇದ್ರದ್ದು ಅಪೋಸಿಷನ್ ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು. ಸೊ ದೀಸ್ ಟೂ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ now not useful. So only resistor is opposing. That's why it acts like a pure resistor circuit. Hence in pure resistor circuit phase difference will be 0. Current will be maximum since opposition has become minimum. Impedance minimum ಆಗಿದ್ರೆ resistance ಗೆ equal ಇದೆ, so current maximum ಆಗ್ತದೆ. And that condition is called resonance, right? So ಈ resonance ಎಲ್ಲಾ ಫ್ರೀಕ್ವೆನ್ಸಿಗೆ ಆಗಂಗಿಲ್ಲ. AC ಸೋರ್ಸ್ ದ ಫ್ರೀಕ್ವೆನ್ಸಿ ನೀವು ಚೇಂಜ್ ಮಾಡ್ಕೊಂತ ಹೋದಂಗ ಒಂದು ಫ್ರೀಕ್ವೆನ್ಸಿಗೆ ಬಂದ ಕೂಡಲೇ ಏನಾಗ್ತದಪ್ಪ ಅಂದ್ರೆ XL ಮತ್ತು XC ಈಕ್ವಲ್ ಆಗ್ತದೆ and resonance occurs. So that frequency is called resonant frequency. Here we have the expression for resonant frequency. Resonant frequency F0 is equal to 1 by 2 pi root of LC. 1 by 2 pi root of LC. So LCR circuit acts like a pure resistor circuit in this case, right? So these are the three cases in LCR circuit. Okay, next we'll go for one more quantity called quality factor, whose formula is VL by VR or VC by VR or 1 by R root of L by R, omega naught L divided by R or 1 divided by omega naught R into C. Formula ನೆನ್ಪಿಟ್ಕೋರಿ, quality factor ಅಷ್ಟೇ. Next, power in AC circuit. See, power in DC circuit is given by V into I only. ಅಲ್ಲಿ ಫೇಸ್ ಡಿಫರೆನ್ಸ್ ಅನ್ನೋದು ಬರಂಗಿಲ್ಲ. ಬಟ್ ಇಲ್ಲಿ V into I into cos pi. ಬಟ್ ಇಲ್ಲೆಲ್ಲ RMS ವ್ಯಾಲ್ಯೂಸ್ ತಗೋಬೇಕ್ರಿ. ಪವರ್ ಇನ್ AC circuit ಇದಕ್ಕೆ average power ಅಂತ ಹೇಳಿ ಕರೀತಾರೆ, right? So power is equal to V RMS into I RMS into cos pi. ಇದು in terms of RMS values. We know the relation between RMS and peak value. V RMS is equal to V naught by root 2 and I RMS is equal to I naught by root 2. So ಅದನ್ನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ 1 by 2 V naught into I naught into cos pi ಬರ್ತದೆ. 1 by 2 V naught into I naught into cos pi. That is the power. Power in terms of RMS values, V RMS into I RMS into cos pi, half V naught into cos pi, right? Power factor cos pi is equal to R divided by Z. This is power factor, right? Okay, next we'll go for one more concept called as last concept, that is transformer. We know transformer works on the principle of mutual induction. There will be two coils, primary and secondary. ಯಾವುದೇ ಕ್ವೆಶ್ಚನ್ ಒಳಗೆ ನಿಮಗೆ ಇನ್ಪುಟ್ ಅಂತ ಏನ ಕೊಟ್ಟರು ಕೂಡ, ಇನ್ಪುಟ್ ವೋಲ್ಟೇಜ್, ಇನ್ಪುಟ್ ಕರೆಂಟ್, ಇನ್ಪುಟ್ ಕಾಯಿಲ್, ಇನ್ಪುಟ್ ಪವರ್ ಅಂತ ಏನೋ ಕೊಟ್ಟರು ಕೂಡ ದಟ್ ಈಸ್ ರಿಲೇಟೆಡ್ ಟು ಪ್ರೈಮರಿ ಕಾಯಿಲ್. ಔಟ್ಪುಟ್ ಅಂತ ಏನೋ ಕೊಟ್ಟರು ಕೂಡ ದಟ್ ಈಸ್ ರಿಲೇಟೆಡ್ ಟು ಸೆಕೆಂಡರಿ ಕಾಯಿಲ್, ರೈಟ್? ದೇರ್ ವಿಲ್ ಬಿ ಟೂ ಕಾಯಿಲ್ಸ್, ರೈಟ್? Input as well as output ಅಂದ್ರೆ primary coil and secondary coil. See, voltage across primary VP, current across primary IP and number of turns across primary NP. Secondary ಗೆ VS, IS, NS. Voltage across primary, voltage across secondary, current in primary, current in secondary, number of turns in primary, number of turns in secondary. Correct? Okay. Induced EMF in primary. ನೋಡ್ರಿ, primary ಒಳಗೂ EMF induce ಆಗಿರ್ತದೆ, secondary ಒಳಗೂ EMF induce ಆಗಿರ್ತದೆ due to change in flux. So that's why induced EMF in primary is minus NP, number of turns in primary, d pi p divided by t. ಇಲ್ಲ change in flux in primary divided by time. Other secondary ಒಳಗ NS d pi s divided by dt, change in flux in the secondary. Main concept ನಮಗೆ transformer related main formula ಇಲ್ಲಿದೆ. This is the main formula related to transformer. This is called transformation ratio. K ಅಂತಂದ್ರೆ transformation ratio, which is the ratio of secondary voltage by primary voltage, number of turns in secondary by number of turns in primary, current in primary by current in secondary, right? ನೋಡ್ರಿ, ಫ್ಲೋ ಒಳಗೆ ಎಲ್ಲ ಸೆಕೆಂಡರಿ ಬೈ ಪ್ರೈಮರಿ ನ ತಗೋಬೇಡ್ರಿ. ಕರೆಂಟ್ ಬಂದ ಕೂಡಲೇ ಅದು ಪ್ರೈಮರಿ ಬೈ ಸೆಕೆಂಡರಿ ರಿವರ್ಸ್ ಆಗಬೇಕು. VS by VP, NS by NP, IP by IS. Correct, you have to remember this. In transformer ಒಳಗೆ two types transformer ಬರ್ತಾವ ನಮಗೆ ಗೊತ್ತದೆ, step up transformer and step down transformer. Step up transformer is used to increase low voltage to high voltage. Step down transformer is to convert high voltage to low voltage. That is the aim of these transformers. So ಇಲ್ಲೇ step up transformer ಒಳಗೆ number of turns in secondary will be greater than number of turns in primary. That's why K transformation ratio will be greater than 1. For step up transformer, transformation ratio is greater than 1. Number of turns in secondary is greater than number of turns in primary. In step down transformer ಒಳಗೆ ಇದು ರಿವರ್ಸ್ ಇರ್ತೈತ್ರಿ. Number of turns in secondary will be less than number of turns in primary, ಅಥವಾ number of turns in primary is greater than number of turns in secondary, and transformation ratio will be less than 1 for step down transformer. Lastly, we should know about efficiency of transformer. Efficiency means we know very well it is ratio of output power divided by input power. Power means it is voltage into current. Output andre it is related to secondary. Input andre it is related to primary. So output power means secondary voltage into secondary current. Input power means primary voltage into primary current. Right? This is the formula for efficiency. ನೋಡ್ರಿ, ಈ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಕೇಸ್ ಒಳಗೆ ಐಡಿಯಲ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಅಂತ ಏನಾದ್ರು ಕ್ವೆಶನ್ ಒಳಗೆ ಮೆನ್ಷನ್ ಮಾಡಿದ್ರೆ ಐಡಿಯಲ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಅದಕ್ಕೆ ಎಫಿಷಿಯನ್ಸಿ 1 ಇರ್ತದ್ರಿ. ಇಟ್ಸ್ ಎಫಿಷಿಯನ್ಸಿ ವಿಲ್ ಬಿ 1. ಎಫಿಷಿಯನ್ಸಿ 1 ಅಂತಂದ್ರೆ 100% ಅಂದಂಗ್ರಿ. ನೋಡ್ರಿ, 100% ಅಂತಂದ್ರೆ ಎಫಿಷಿಯನ್ಸಿ 1 ಅಂದಂಗ್ರಿ. 90% ಮೀನ್ಸ್ 0.9 ಅಂತಂದಂಗ. 80% ಅಂತಂದ್ರೆ ಇಟ್ ಇಸ್ 0.8. ಸೊ ಅಲ್ಲಿ ಏನ್ ಕ್ವೆಶನ್ ಒಳಗೆ ಕೊಟ್ಟಿರ್ತಾರ ಆ ತರ ನೀವು ತಗೊಬೇಕು. 70% ಅಂದ್ರೆ 0.7. ಲೈಕ್ ದಟ್ ವಿ ಹ್ಯಾವ್ ಟು ಟೇಕ್. ಕ್ಯಾಶುಯಲಿ ಪ್ರಾಕ್ಟಿಕಲಿ ನೀವು ಯಾವುದೇ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ತಗೊಳ್ರಿ, ಇಟ್ಸ್ ಎಫಿಷಿಯನ್ಸಿ ವಿಲ್ ಆಲ್ವೇಸ್ ಬಿ ಲೆಸ್ ದೆನ್ 1 ಅಥವಾ ಇಟ್ ಇಸ್ ಆಲ್ವೇಸ್ ಲೆಸ್ ದೆನ್ 100%. ನೋ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಇಸ್ ಪ್ರಾಕ್ಟಿಕಲಿ 100% ಎಫಿಷಿಯಂಟ್. ಯಾವುದೋ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಪ್ರಾಕ್ಟಿಕಲಿ 100% ಎಫಿಷಿಯಂಟ್ ಇರಂಗಿಲ್ಲ. Right? It will be less than 100% only. But ಈ ideal transformer ಅನ್ನೋದು it is an ideal concept. Right? Theoretical concept ಇದು. Right? ಇಲ್ಲೇ ನಾವು efficiency 1 ಅಥವಾ 100% ಅಂತ ತಗೋಬಹುದು. Input power and output power both will be equal. Right? ಇದು 1 ಆಯ್ತಪ್ಪ ಅಂತಂದ್ರೆ ಇದು 1 ಆದ್ರೆ input power ಮತ್ತು output power ಎರಡು equal ಅಂದಂಗ್ರಿ. So input power means, see, I have written in reverse here. Input power means it is primary voltage into primary current. Output power means it is secondary voltage into secondary current. So this is VP into IP is equal to VS into IS. Correct? This is what we can take. Input power is equal to output power and efficiency is equal to 1. For which? For ideal transformer. Right? So, dear students, so this is all about AC. Right? So the complete chapter we have revised here. So by this we have completed half syllabus of second PUC. So in the next video, I will start with ray optics, and then ray optics, wave optics, dual nature, atoms, nuclei, and semiconductor. So we'll complete as much as possible. I will try to do the video every day. Somewhere in the middle, I may take a gap of 1 day or like that, right? ಕೆಲವೊಂದ್ಸರಿ ನಂಗೆ ಟೈಮ್ ಔಟ್ ಆಗೋದಿಲ್ರಿ, ಕೆಲವೊಂದ್ಸರಿ ನಂಗೆ ಟೈಮ್ ಸಿಗೋದಿಲ್ಲ. ಸೊ ಅವಾಗ ಒಂದಿನ ನಮಗೆ ಗ್ಯಾಪ್ ಆಗೋದು. ಬಟ್ ವೆರಿ ನೆಕ್ಸ್ಟ್ ಐ ವಿಲ್ ಪುಟ್ ದ ವಿಡಿಯೋಸ್, ರೈಟ್? ಸೊ ವಿಲ್ ಕಂಪ್ಲೀಟ್ ದಿಸ್ series first. Many of you are requesting for first PUC videos also. I will try to do on that also. First, let me complete this series, right? This secondary chapters now complete ಮಾಡ್ಕೊಂಡು, and then we'll see. Many of you are requesting for MCQs also. After completing this, we'll do those things, right? Dear students, if you like the content of this channel, please don't forget to subscribe the channel, right? And please share the video, share the channel with your friends. Please refer the channel for your juniors also, right? Thank you so much for watching and supporting the channel. Please keep watching and supporting the channel. Thank you.